So thus far, we've looked at a rather small data set of just 4 sampling dates, looking at bird collisions. But I want to go back to this idea of cactus height and this slide I shared earlier on showing this basin and this ridge area where you might sample quadrats and you might collect a lot of data and put it into a spreadsheet, and you're trying to tell, are cacti taller when they're on a slope or a ridge, or maybe they're taller down in the basin? Is there a difference that is significant or not? So let's just review how we would look at this. In this case, we have many more measures. This is the height of cacti within those quadrats in meters. And so you have some very tall cacti and you have some that are less tall, but you measure them all from your samples. And now if you go down, you can actually see you have many more measures from the basin than the slope cliffside. And that's okay, because we can still summarize the data and learn about it. It's okay that the data does not have the exact same number of samples or recorded data units. So one thing I do like to do as I scroll down on larger data sets is I like to freeze the pane so I don't lose these headings, because otherwise when you get down here, you're like, wait, which one was which? So a very simple thing you can do in Google Sheets, it's also in Excel, is you go to View, and it might be in a different location in Excel, but you can freeze the top 2 rows in this case, because the top two rows are the headings. And now as you go down, it will lock them in place. So that's just kind of useful. So the first thing we want to do, just to get a sense of the data, as always, is let's figure out the average. So I'll start to type average here, and I then have, it's asking me for what I want the average for, and I actually want it to be the basin, so I'm going to click that data set and scroll down to the bottom and hit enter. And it is suggesting an autofill. I'm going to say no, because I want to make sure we get the right data for the sloped cliffside. So the average here, and what we can do is highlight. It actually looks like maybe it has its right. Let's just see. It's B3 to B22 for that data set. So we have an average of 3.8 and 4.2. And if you want more significant digits, you can always go here, decrease or increase decimal points. So I like mine at just about there. That gives me a good sense of it. Let's do the standard deviation. So I start to type ST, and there's standard deviation. I'm going to go here, and this time I'm going to hit on a PC Shift and Control and down, and it just goes all the way down to the bottom of the data automatically without me having to scroll. Click that. Again, it wanted to autofill, but let's just do it manually. Standard deviation, and you can see it's got the wrong actually it's got maybe the right side, B3 to B22. Yep, B3. Let's go down, B22. Yeah, so that's correct. So it's always good to look at this, and if you're ever unsure, you can highlight any cell, and then you go up and you look and you see that there's the formula of where it's generating. So in this case, we've got a slightly higher height on average in the basin than in the sloped cliffside, somewhat similar standard deviations. And the question really is the difference in means significant given the variation in the data? And that is a question that only inferential statistics like a t-test or a chi-square, we're going to talk about those in the next module, those are what can help you determine, is it significant or not? Because any two data are going to have a difference in the average. You're never going to have the exact same average. So there's always going to be some difference just by chance. And the question is it significant? And that's when you get into things like p-values and setting up a t-test and such. So again, we'll come back to that later, but that is sort of the teaser for the next module that you will be getting into.